So today I'm just going to test the website. The plan so far is I'm gonna show, I think, I, I didn't do much, I guess, since last time, but there was some progress at least. And the idea is that obviously I'm going to use my own website, and then I'm writing down the pain points that I have as I try to do this in order to see what direction to go with. So these ones are meant to be, the idea is that I have one or two types of exercises that are faster to do, and then one that is lower. And I even contemplated on going back and doing LeetCode, which I may do as well. So from time to time, like I'm gonna try to use my own website first to become really good, and then from time to time, go to LeetCode to see if it's working or not. And the thing that I wasn't sure is whether or not I'm lying to myself. And the reason why I don't like doing LeetCode is just because I'm bad at it and I feel resistance to do it, or if it is because it's inefficient. And I think that it is more because it is like it doesn't focus, it doesn't go straight to the core of the thing. That's what I'm trying to, I was discussing this with GPT as well. And that's what I'm trying to figure out. But I'm not still 100% sure about this, but I do think that there is a very good chance that I'm right. Because on LeetCode, the issue is that, like, when there is another part of the problem that is not related to the stuff that I'm trying to train. So when I have a problem like this, for example, you have like the first solution that I think about, I can't really implement, or I'm not really sure if I can implement because I don't know the Rust semantics in the mechanics yet. So yeah, that's what I'm trying to do here. And these ones are supposed to be like very fast to do and easier. And these ones are just to type the method you have. So I think that I'm not really sure about how many there are. I'm probably going to try to expand later, but I'm still testing to see what's good and what's not. So this one is supposed to, but the concern that I have with this one is that it's going to be like one of these Anki traps that just leads to more memorization than understanding. But obviously I have to combine all of them. And this is the new one that I was gonna test right now. But I think I'm gonna do a few of the choice first, and then the recall, and then the mechanics. But the mechanics is like, it's kind of between the recall and the construction. So it's not fully to just type it out, but it's also not as complete as the construction. And the construction is kind of like LeetCode, but I'm gonna try to make it focus on the actual thing that matters. So like instead of having like the fake context of the exercise, I'm just gonna focus on the transformation of types and manipulation of the data structure as well. But then like what I realize is that each problem like this, there's too much friction, because when I think about a problem like this, I start thinking about like how I'm gonna do this, and usually I can come up with a sequence of pseudocode steps to do it. But then it becomes very hard to translate into Rust because I don't know the semantics. I don't know the mechanics. So for example, when I call this function here recursively and I pass the, first thing that I struggled is to think about how to access the left and right nodes. So I saw the solution there, I already know. So the way you access is by calling this stake function. I don't remember if you use the, this is another thing that I was confusing with C++ because of just how I was with C++, that I was gonna use the arrow as well. But I think you call this stake function, because you're trying to get the value from the option. So the option is like a type that wraps the value you have, and it allows you to check if it's a null or if it's none. So it's either going to be a sum or a none. And then the box is kind of like a unique pointer in other languages. So first you have to do this, then you pass this on. I think this, if I remember correctly, the solution you match the root first, and the way this is another thing that I didn't know is that, or I didn't think about automatically. You can just match on the root directly because you have an option. So if it is none, you're just gonna throw here. It's just gonna go into the none option on the match. Then I think that here they do it like this, where they call recursively. I think it's, I don't remember really well, but I think it's something like this, the solution. And then they call recursively here, passing. Yeah, they make it the. Well, now I'm not sure. No, I think that, yeah, they make the root left equals passing the right. The pass recursively the other one. There might be like some things that I don't remember. And then they return the roots, I think. Recursion is very confusing. I struggle with that a lot. Then the none, I don't remember here. What did they do? But it's something like this. Maybe they don't do anything. I'm gonna have to look again. We got the idea. The biggest point of friction is that I can think about there's actually two main axes. One is that I can think about a solution that comes to mind right away, but then I'm not really sure. Most of the time, it's not going to be the optimal solution. So that's one problem. It's like, how can you know what the optimal solution is? Because if you just solve, and obviously on LeetCode you can do this as well. Like you can solve based on whatever way you come up with, and then you look at this other people's solution to see how they implement it, and then you compare. But the issue I have with that is that it's too slow. So that's what I'm trying to see if I can make it faster. So that's because it's more training how to think. That's the point. Like I don't want to train to solve a specific exercise. I want to train so that I intuitively already think about the best solution possible instead of having the habit of just going with whatever comes up with my mind. Because obviously it's not going to be ideal. So like the first thing that I was thinking about is to check to see if you have a left or a right node. This is what I was thinking about doing initially. And then making that the base case, and then on the base case you swap the values basically of the left and the right node, and then you just return, because then on the backtrack is going to swap everything else. That was the idea that I had, but then the first question that I had is how I'm going to check this correctly. And these types of things, it just slows you down because there's a lot of friction because of you don't know the language very well. So because of that, I talked to ChatGPT, and then now we are trying to build this mechanics type of quiz, which is like in between the recall, where you just type a method, and a full reconstruction of an algorithm, so that you train specifically the mechanics you need from the language to become better, like at these things like how to match or ownership, or how to call certain values of the how to do certain operations with building data types of vectors and strings. I think this it doesn't, no, it just returns none here, if I remember correctly. So left, it is root left. Root like, yeah, I think I remember. Oh, it's nodes, it's not. That's because of this. The other thing I forgot is this mute here. Nice. I think I remember everything correctly. Maybe it's this. This is interesting. Might be because of the actually that's because of value here. I'm using root with its value. A match though. Right, finally. And the other thing that I have to see, but I think it's good to only have this few exercises here, and they're all very easy actually. This one is the hardest one that I have here, but I think that's good because the main purpose now is just to train to see like what are the pain points, and the goal is to make it like as fast as possible to train straight like the stuff that matters for the mechanics. I think the best way to go about it is to first spend a bunch of time on these three ones, which is like the easiest ones, to integrate everything, every sub operation you need inside of an algorithm to do anything you have to do, and only then expand on the construction because a construction is a composition of sub operations. And then these ones are for later, I think, which is also nice. That allows you to see the outputs. And this another thing is about the settings, which the goal is to have like a mathematical equation that creates the distribution of how much time to spend on each quiz, but it doesn't force you necessarily to spend a bunch of time, like to spend the correct frequency of time if you don't want to. It's just like an optional, which I also think this is a good idea to do in order to make sure you're balanced. Because the natural tendency, obviously, is always going to be to do more of these easy quizzes. Because humans don't want to spend energy thinking because it's very expensive. And this is the thing that I wasn't sure about the lead code. Like, I might be lying to myself because it's a rationalization. But I do think that there's stuff, and this is common with a lot of lead code problems where, or any of these websites problems, is that it has a bunch of stuff that doesn't necessarily matter for the programming in itself. It's like the context of the problem. And it's not that it's bad either, is that it's just a different type of thing. That's why I'm contemplating whether or not to go back to this and maybe spend a bunch of time doing lead code puzzles as well once I improve with the website. And this is just the analytics. And I didn't do anything with the settings yet because obviously I'm just testing out the things first. I think once I develop everything and I have like a stable and a bunch of exercises and a stable routine, then what I'm gonna do is just tweak the numbers here to see what distribution is better probably. So let me do some choice first, then I'll do recall and then do mechanics. The value for an entry. And a lot of these exercises on the choice and recall are extremely easy, but it's good to be that way because you want to create a ladder. So this is another thing, like you don't want it to be too hard or too easy because then you don't get into flow state. I think that there should be ones that are very easy and you can do like a bunch of times in order to get like space repetition memorization of the what each method is. In the value for an entry, certain the explicitly provided value when the key is absent. I think it's or insert this one. Inserting explicitly or insert, nice. Return true if every item satisfies the predicate output bool. And short circuit on first failure, which operation? First failure. I think it's filter map from what I remember. Yeah. Every item satisfies the predicate. So I think that it stops on the first failure. So if the first item that doesn't satisfy the predicate, it stops. Go remove and return the last T or none when empty. Output option T operations. I think it's pop. Pretty sure. Okay. Easy. Go up a key by borrowing using share value. I think it's get. Yeah. Depends. Go to the end of the vector. Push probably. I think extend changes the vector in place. Or I think extend returns a zero size type from what I vaguely remember. So maybe it is extend here because of the output. Then a single this push. I'm not sure what's the difference between extend and push. And maybe this is the thing as well that at the first iteration of this, I'm trying to do the problems in an automated way. But like I'm discussing this with GPT as I'm implementing, and I think it's best to try. And GPT agrees that it's best to try to do it the automated way because obviously then it scales. But obviously, I'm not averse to doing it problems manually. So this is something that I'm thinking about here. Is that like maybe because the issue then like I'm contemplating whether or not I should put the first thing that I thought about there is to ask the question what is the difference between push and extend, and obviously I thought about putting the explanation or making so that this exercise has a explanation there, but then it goes into this whether or not to do this now or delay because maybe now is not the best because I'm creating this problems with the agent. So I'm not sure. I think it's probably better to try to do the automated way first and then scale to a bunch of exercises. Then once I have like a solid system, then I start like manually crafting the exercises when I encounter stuff like this. And that's probably a better way to go about it. Okay, so you need to keep the option and transform the value inside. I don't think it's this sum nor is none. It's probably on map though. Map. Yeah, map makes sense actually because map. Every time that I look at map now, I remember the monads thing. So just gonna change. It's gonna keep the container and change what's inside. Yeah, that makes sense. I think unwrap should get the value inside probably. Where's license traverse its elements? Share reference. Ether probably. Yeah. The inner value. Custom panic. I think now is unwrap. Hmm. So maybe it's the panic thing. Fact unwraps but attaches a custom panic. Or no? Yeah. I'm not sure. Yeah, again, the first instant that I have is just search for the unwrap thing. So maybe, let me think about this. Because the idea is to avoid using documentation as much as possible. Because the documentation usually is low and has a lot of noise as well. So anything that I would need to use documentation for is better to try to incorporate the most condensed way as possible. But I'm not really sure if it's worth it again, because of the stuff that I was saying about automated versus manual implementation of the exercises. Currently, the other side of a result. Operation accomplished. I think this one, yeah, I remember this one. The map error transforms the error. I think it makes sense based on the name because the map transforms the element inside, and the error is intuitive to understand. Yeah, counts, obviously. I think filter produces a iterator as well. I don't think it is a collection. I'm not 100% sure. But I do remember from other exercises that usually called collect, the collect function. So I think iterator, I think filter returns something else, probably either one of these, I think. Yeah, this is actually a difficult one. Well, it actually makes sense now that I think about it. So it's basically saying that the item is going to be only the ones that are kept, but I don't understand the type very well. I don't understand what this means necessarily. The item is the thing, the item I think is an associated type inside of the iterator, which is the type of the item that the iterator is about. So if you have a vector of integers and then you call into iter that on the vector, it's going to transform into an iterator and the associated item type is going to be integer. So I think is making that equal to a generic, but then I don't understand like how does it work internally. I think this one is probably a map. Lazily filter and transform items in one pass through option. Yeah, the map on Rust is lazy, which means the moment you call the map, it doesn't evaluate, it doesn't run what's inside of the map right away. It only runs when you call, or either when you use the value, I think, use the iterator, or when you call something else, I think. So I think it is a map. So, filter map. Oh, I didn't read here. I think I thought that was a filter already. Yeah, but that obviously makes sense. So I'm gonna do the recall now. And is recall is likely harder because then obviously you have to type the correct one. You don't have the options. Yeah, I have no idea about this. Maybe I have no idea. Okay. That's mute. Yeah, I have no idea about this. Just gonna as is the same one. Turn the value or provide a fallback, never panicking. Yeah, no. Maybe zone wrap. Wow. Zone wrap R. This is the one that I'm concerned that is gonna become like an Inky trap because I'm gonna do a bunch of times and I'm just gonna memorize, but I'm not gonna be able to use it because I'm not gonna have the context of how to use it when I'm programming something a bigger. Change selection. Reverse elements with immutable access. And because of the reverse, I think is this. Okay, intermute. And traverse, I read reverse. On the map, and traverse this. Maybe it's keys. I don't know. Okay. Safe indexing, returning a shared reference. I think it's unwrap or yeah. No, it's not unwrap. Something else. Maybe it's get or. I'm not sure. Okay, get. Every every element of an iterator to the vac. Yeah, I have no idea. Because it's append every element, so no idea. The extend is kind of like a list, if I understand this correctly. Kind of like a list on Python, I think, where it's basically pushing the entire vector to the other one. In this case, it's pushing an iterator to the vector. Now this one is a map. So I'm gonna do the mechanics now. I have no idea. Remember it. I even did this before. I didn't remember what it is. Hmm. I'm gonna guess is map, but I have no idea. Flatten. So flatten is going to downgrade on the option to the type on the iterator. It makes sense. Flatten. Maybe this can be improved as well. Like, I'm not sure how that would work because I think the Monaco editor is probably another component. I'm not sure if you would break the flow here. I want to write down. I think I don't remember this very well, but I think it's something like this. I don't remember if you call zip directly or if you do iter first or iter mute first. Then you call zip and you pass the other one. And then I don't remember what you do. But a zip iterator from I remember from Python is like it allows you to loop over two values like at the same time. I think usually is used when you want to loop over values of a tuple, for example. So it loops on parallel on both values. Yeah, I don't remember, but I think here you would obviously call something else here, and then you would sum the values. Or the other way would be to. That's the thing that I still like. Like I can think about another way to do it, and this happens a lot of the times as well. But then I immediately know also that it's probably not the best because it's gonna lead me to do more things that are not good probably. So the challenge is like how do you train that type of thing? So there's two components here. One is not knowing the Rust syntax to finish this version here, and the other one is like how can I know, how can I build a system that allows me to know what makes me go to the solution that is probably not the best instead of going to the solution that it is. So like the other way that I'm thinking about implementing this is to this is another thing I'm not really sure how I would loop or if this way of looping would be correct. Let's say, but the downside of this approach here, let's say you loop over A like this, is obviously that you would have to check for the length of the vectors to make sure that they are the same. And for that reason, I don't want to do this, and you would get more annoying where you have to do checks either first or before, or either before or inside of here, and then you just would add the elements of each vector, and then push to another one. But then I already know that it's probably not the best. And I think that this is probably both an issue of not knowing the mechanics of the language, and also an issue with the algorithmic thinking. But it's very hard to think about like how to create a system that allows me to think about to improve the way that I think, because that's the goal of the exercise. Like the problem with LeetCode and the other sites is that they show you a lot of examples and then you have to train yourself to derive the rule. And I want to see if I can do the opposite. Like go from the rule and then you see examples later. It makes more sense. So I don't remember how to do the rest here. I'm just gonna look into the solution. So it does do the iter, and then it passes B as an iter. Another thing that analyzing the maps over both. This feels kind of weird. The maps after, and then it has the tuple. So X is going to be the value of A, the value of the elements of A, and then Y is the value of the elements of B. Let's see if I remember this. So I have A iter, then you call zip the iter. I think I do remember. A map X. Here's is the lambda syntax on Rust. Then you do X plus one collect. This collect also. I'm gonna wait to watch videos and see on the documentation because I don't understand really well, but I know that it's used all the time, and I don't know why. But usually after some operation like iteration or maps or filters, people use this collect here. I have no idea why though. Let's see what zip iter. Also, I didn't do this tuple thing here. Inside of the lambda is only one argument, and the zip creates tuple, I think. Not sure if it is a tuple in Rust or I think it's just the type of the item. Not sure if this is considered a tuple or not. Map texture. Yeah, I think that's the only thing that I did wrong there. Iter and zip iter map x y. Should be correct though. The other thing that I don't understand is how can I use why can I use the iter and not and I don't have to use the iter mute to loop over the or to change the values. Guys, this is because I'm not changing the values. I think that the answer is because I'm not changing the values, I'm just using them to calculate sum. But then I think that is unclear because the map is gonna be lazy, and I think it's gonna depend on how the collect works. So whether or not the collect is gonna, I assume that based on the answer there, the collect is probably gonna force the expression inside of the map to run. But then, given that they're both ithers, I think that they don't change the values of A and B. They change other values. With the item type. You change elements in place, you need mutable references. So it's probably mute. See? Also is the other, the I'm not sure if it's a percent that just say this. Is behind the mute. That's exactly what is there. I'm not sure if the exercise is wrong. It's exactly what I wrote. So I'm gonna write this now. If I do Control C, Control N, I'm pretty sure it is. Yeah. Size. Yeah, I think I'm gonna guess that is the collect here. Operation that's gonna turn the iterator into a vector. But I have no idea. Maybe it is collect, but with the so I guess this is the reason why people do this all the time is because it turns the iterator into a vector. But I still wanna see and understand like the mechanics, the what happens under the hood in memory. Have a vecti once you keep using it afterwards. Which of iter moves consumes the vac. I think it's iter mute, but obviously I'm not sure. Maybe a trick question. But yeah, intuitor. Okay, so the last one is that intuitor consumes the vector. Self by volume consumes. Takes self by volume, consumes the vac. Oh, let's see. Well, the other thing that we're gonna try to improve right after this as well is to create categories. There's another like there's two things. There's a couple of things, but the ones that I remember now is to do categories so that I know like I can select a specific type to train. So vectors, strings, and this kind of stuff. and the other that is similar is to on the construction type of exercises should do the thing that I was trying to do with the data structures there on the other repo. Is basically data structure reconstruction. So the exercise itself should rebuild like a either rebuild or partially rebuild data structure. I think that would be very good as well. I think it's retain. Yeah. This one gives you a lot of hints here. So these values, ether, or retain. Collect, probably. Doesn't say the type that it has to return. I'll build another collection. Alright, for the function body. So maybe it's just like this. Unless I don't have the ether, it's straight into the vector. Yeah. Pretty easy. I think it is like this. Yeah, I'm gonna stop here. So I'm going to continue to build this off stream. Or maybe I'll continue to build this tomorrow on stream as well, depending on what I'm gonna do off stream. And I think this is a good direction to go. So the idea is to train using the exercise, then write down the friction points, and then continuously improve the website until all friction points have been removed to accelerate the feedback learning or feedback loop system. So yeah, probably I'm gonna stream tomorrow, and I think I'm gonna do like a few other or one or two more runs with an agent to try to fix this or to improve these things here. And then tomorrow I might continue to try to build this on stream or just review the code as well. So see you then.